Inequalities. So today we will be doing the second day of inequalities. So what did we do on the inequalities last week is we discussed about the rules of inequalities, and I told you there are two types of questions that comes under inequalities. The first type is solving an inequality, and the other one is proving an inequality. So there are two types of inequality problems. One is solving an inequality, and the other one is proving an inequality. And we started the solving part of an inequality, and under the solving part, I told you, if you can remember. So this one we'll be discussing according to two ways. The first way is how to solve a linear inequality, which is really easy. How to solve a linear inequality. So I'll remind you how to do it. If we have that x plus 1 is greater than 3, simply when you have to solve a linear inequality, what you have to do is you need to subject x. So when you subject x, you get x is greater than 2, and this is your final answer. When you're supposed to solve a linear inequality, you should subject x. And then the next thing that we have to discuss is how to solve a non-linear inequality. Did I give a topic? No, topic. I gave a topic, no? So I have given a topic. If you were absent last week, write the topic. Solving non-linear inequalities. I gave that topic last week. If you were absent, write the topic. Solving non-linear inequalities. Solving non-linear inequalities. Okay, solving non-linear inequalities. Okay, now this is the thing. Even though you were absent last week, that's okay because this part is a new part and everyone here can easily understand this. No any previous knowledge is required. We only require the knowledge of writing this shaded region in a number line. So that is the only thing that I require. So how to solve this non-linear inequalities? So I'll take an example. So what is a nonlinear inequality? I told you what is a linear inequality. A linear inequality is simply when we have these x terms, like x plus 1 is greater than this one, 2x minus 1 is this one. When we simply have these x terms, we name it as a linear inequality. So I'll write a example. This one, I'll take the first question of the tute. X squared minus 2x minus 3. This one is greater than 0. Okay, so here it is clear it's not a linear inequality. It's not a linear inequality because you got these x squared terms. A linear when x කියනවා විතරක් එහෙම තමයි we call it linear. So this is not linear, this is non-linear. These are non-linear inequalities. Okay, so when we are solving this non-linear inequality, we use this method, a special method called sine curve method. I'll give the note. So there is a special method as sine curve method. So we do here is, what we do here is, the first step of the sine curve method is that you need to make one side 0. The first step of the sine curve method is that you need to make one side 0. එක පැත්තක් 0 කරන්න ඕනේ. So even though they have given terms in that side, you need to take the terms to this side and write it like one side should be 0. So that is clear. The first step has been done. And the second step is that you need to simplify this side. If there's any simplifications, you have to simplify and you have to factorize this as much as possible. Now you have to factorize this. Factors kadanna puluwan furthest point you have to factorize it. So second point, if there's any simplification, do the simplification and then factorize. So when I factorize this, so we know how to factorize a quadratic factor, x minus 3 and x plus 1. If you factorize this one, it's x plus 6 into x minus 1 is less than 0. So step number 2 is done. What is step number 2? We have to factorize this. And then the third step is take a number line and mark the values that make each factor 0. Mark the value that makes each factor 0. This becomes 0 when x equals 3. This becomes 0 when x equals minus 1. So consider a number line and mark the values that make each factor 0. So this becomes 0 when x equals 3. This becomes 0 when x equals minus 1. Clear? Okay, so that is step number 3. Consider a number line and then mark the values that make this 0. And then I want you to do this one. So we have three ranges or regions. We have three regions or zones. This is the first region. This is the second region and the third region. Now I want you to do this one. Okay, everyone should do this. Think of a value in this region. In මේ region එක මොන හරි number එකක් ගැන හිතන්නකෝ. Any number, but you can even think minus 1500. But don't go that further. Just like think of any number minus 2 or minus 3. Okay, I'm not asking the value. I'm not asking the value. Tell me, when you substitute that value to this x, what is the sign of this factor? I'm only asking the sign. I don't care the value. What is the sign? It's negative or positive. It's negative. For example, if you take minus 2, minus 2 minus 3 is minus 5. I don't want this minus 5. It's minus. So it is clear whatever the value you take, you will be getting a minus value. So that's why I ask you, everyone think of a value. So even everyone here thinks of 60 different values, you will be getting negative values. And then do the same thing. Substitute that to this factor. So if I substitute minus 2 plus 1 is minus. So which means in this range, this is even minus and this is even minus. Clear? This is even minus and this is even minus. Second thing, now think of a number in this region. Okay, you have to do this. Think of a number in this region. Okay, this number. And now substitute that number to here. Ametana substitute karanda. Substitute it here. Now tell me, the sign is negative or positive? The sign is negative or positive? And it's negative. It's negative. And now substitute that value to here. If you substitute the value here, it is positive. For example, if you take plus 1 in this region, 1 minus 3 is negative, but 1 plus 1 is positive. Clear? And then, if you take a value in this region, let's go with 4, even this is positive, and this is even positive. So now it is clear, in this region, this product minus is plus. This product is plus. In this region, minus plus is minus. This is minus. And finally, in this region, plus into plus, it's plus. So what did I do? I have considered a particular value in the given region. Whatever the value that I substitute in this region, this product or this expression, we just took the sign of this expression, this product or this expression, it's positive, it's negative, and it's positive. So here it is clear. I have taken this region and then I have considered the sign of this inequality in this particular regions. And look at the question. The inequality is asking what is the range of x such that this expression is greater than 0. So greater than 0 means positive. No? Greater than 0 means positive. Less than 0 means? Less than 0 means negative. They are asking what is the range of x that x is positive. Then you can select your range. Okay, I can see x is positive. Sorry, not x. This expression is positive in this range and it's positive in this range. So this expression becomes positive in this range and this range. So then you can write the answer. What is this? X is less than minus 1 or x is greater than 3. So you can write it. What is this? X is less than minus 1 or x is greater than 3. So that is the range. So I'll repeat it with the second one. So what we do here is after finding these signs, look at the inequality. We need to find the range that this particular expression is positive. So according to this one, it's clear. Here it's positive and here it's positive. Okay, so then you can write the final answer. The fourth step is that you have to consider the sign of the regions, the sign of the expressions in different regions, and then you have to write the final answer. So if you can do these 5 steps, you can solve any nonlinear inequality. So I'll repeat it here. To make it a theorem madivagina making hand, I'll repeat the same here. Take a number line and mark the values that makes each factor 0. This becomes 0 at x equals minus 6. This equals 0 at x equals 1. Again, let's do it. I'm asking for a side. I need the answer. Okay, now think of any number in this region. Think of any number in this region. Okay, tell me corner side. So take any value in this region and substitute here. Tell me whether is it positive or negative in this region. Again, this is positive or negative? Huh? Say it properly. In this region, if I take a value and substitute here, what is the value? It's negative. මොකද කරන්න කියලා අපි rocket science එක බලන් ඉන්නේ. So what we have to do, take a value in this region. මෙතනින් value එකක් ගන්න. ඒක අරන් ගිහිල්ලා මෙතනට substitute කරන්න. So if you take minus 7 plus 6 is minus 1. So I need that minus, it's minus. Okay. Our answer we have to properly say whether it is negative or positive. දෙකම shape වෙන tip ගන්න එපා. There was a Japanese video in a Japanese laboratory. The teacher, not the teacher, the lecturer is asking a question. The question was related, like let's say when the temperature increases, what happens to the volume? And let's say it increases. They don't know the answer. So they answer in this way. The lecturer is asking, okay, when the temperature increases, what happened to the volume? The entire class is increases. Whatever it either increases or decreases. No? So the answer is when the temperature increases, what happens to the volume? It increases. Increases. So the lecturer is thinking that they are giving a particular answer and he is thinking that he can't hear it properly. So he's again and again asking. The entire class increases. So don't do in that way. Yeah, positive or negative, either both it's tiv. Okay, now this same side. Okay, now because you have in 3 regions to the 3 sides. Okay, now tell me, substitute that value to this factor. What is the sign? Positive or negative? It's negative. It's negative. And now come to this range, middle one, this range. I think of a number and substitute it here. What is the sign of this one? It's positive. Now take the same one and substitute here. It's still negative. No? If you take like minus 4, minus 1 is negative. This side, tell me, take any value after 1. When you substitute it here, it's positive. It's positive. And now substitute the same one here. It's again positive. So it is clear. Now in this range or this region, we have taken this is positive, this is negative, and this is positive. But in this case, we need to find the region where this expression is less than 0. Less than 0 means negative. Less than 0 means negative. Then I need to find the region where this is less than 0 or negative. And negative means in this region. So this is the region. That is the answer of the inequality. So this expression becomes negative when x is greater than minus 6, but it is less than 1. So this is what we consider as the sine curve method. So if you follow the same steps, you can solve any nonlinear inequality. Clear? Maybe the nonlinear inequality within our syllabus frame, you can solve anything. Okay, hands up if you understood this one. Okay, write in this way. Right? To solve nonlinear inequalities, nonlinear inequalities, we use We use the, write in a red pen, sine curve method. We use the sine curve method. Sine curve method. Same line. When applying this method, when applying this method, when applying this method, the following steps, the following steps should be followed. The following steps should be followed. Under that, write the first one. You can either put 1, 2, 3, or any star mark or any dash, anything. I just need these 5 steps. The first one, take all the terms of the inequality. Wait, take all the terms to one side. Take all the terms to one side of the inequality. Take all the terms to one side of the inequality, making the other side 0. Making the other side 0. Making the other side 0. Second one, next step, simplify and completely factorize. Simplify and completely factorize the expression. Simplify and completely factorize the expression. Next step, mark the values. Mark the values of x. Mark the values of x which make each factor 0. Which make each factor 0 on a number line. On a number line. So we have to mark the values that make each factor 0 on the number line. Next step, consider the sign of the expression. Consider the sign of the expression. Consider the sign of the expression in each region. In each region. Final one. Write the final answer. Write the final answer. Write the final answer according to the inequality, required inequality. Write the final answer according to the required inequality. Okay, then do these two. Just get an understanding from this question number 1, and I need you to do the second question alone. Just to get an understanding, look at the board when you're doing question number 1 to get the flow of the question, how to do it, how to present it. But question number 2, do it alone. Now after this, I'll give you like 2, 3 questions, and if there's anything unclear, even a small thing, you can ask me when I come, because I need you to be crystal clear in this. If not, you won't be able to understand the remaining part that we will be doing today. Don't just copy paste the board. Try to understand what we have done here. Get an idea from question number 1 and do question number 2 alone. Okay, so I'll again explain what happened here. Is this blue colored one I have denoted in the blue color one is the sign of each factor in this region. And then minus minus gives you plus, no? So minus minus gives you plus. Okay, that is clear. And then this region is plus, minus, and plus. And then how can you mark the shaded region? Is we are required to find the region that this is greater than 0. Greater than 0 means it's positive. So greater than 0 is positive. So then you have to mark the region that is positive. So what is the positive region? This one and this one. And then I'm shading it and then you can write this final answer. Clear? So when it comes to this one, in this one, they are asking that the region that this is less than 0. So less than 0 means it's negative. Then you have to consider the region it's negative. It's negative in this region. So that's why in that case, I have marked this one. Even in this one, if they ask in the positive region, then you have to mark this and this. Okay. Now question number in the tute, inequalities tute, 3, 4, and 5. Okay, I'll take question number 3. First step has been done, like one side they have made it 0. And then factorize this. When you factorize this, it's x plus 4 and x minus 3. And then mark the values that make it 0 on a number line. It's minus 4 and 3. So when you mark it, you get minus 4 and 3. Clear? And then think of a value, any value in this region, and it is minus, and even this is minus. Think of a value in this region. If you take plus 1, this is now plus, but still this is minus. Any number greater than 3, these two will be plus and plus. Which means inside this range, you get, okay, this is plus, this is minus, and this becomes plus. Clear? You are getting plus, minus, and plus. And then look at the inequality that we are required to find the region where it is positive. So it's positive in these two regions. It's positive in these two regions. Okay, they write the final answer. So when you are writing the final answer, it's basically just write in this region. There's no any connection between the way you write this answer and this inequality mark. According to this inequality mark, we shade the region and then write in this inequality or the shaded region is something that we learned last week under inequality. So x is less than minus 4 and it's greater than 3. Okay, so this one factorize, it's x minus 5 and x minus 3 when you factorize it first. And it becomes 0 in 3 and 5. And now look at this. When you are marking this sign, look at this. The sign I required is this final sign, this red colored one. I don't require this intermediate signs. මේගොල්ලන්ගේ sign එක වෙන වෙනම ඕනේ නැහැනේ. What I require the sign of this entire expression. So if you can do this in this way, like I know students even do this, even I will be doing after a few questions. Think of a number less than 3. If you go with 1, even this is minus and this is minus. You know minus minus is equal to plus. So then you don't have to keep writing these two. Clear? If you can see, okay, it is plus, a minus minus gives you plus, you can directly write it. And this one, if you consider 4, this is minus, 4 minus 3 is plus, a minus plus is minus. Anything greater than 5, if you take 7, 7, even this is plus, 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 and plus is plus. Clear? If you're sure about this one, then you can directly write the sign without writing this intermediate things. Here, even you have to find the region which is positive or greater than 0. Then you can consider these two regions. These two regions. So write the final answer. X is less than 3 or x is greater than 5. Last one, first factorize this. 12 and 2, x plus 12 and x plus 2 is less than 0. Mark this on a number line. Minus 12 and minus 2. Same drill if you want. If you can write this in this way, you can just write it. It's much easier. So anything less than minus, let's say minus 14. Think of a number, so that is better. Think of a number. Minus 14 minus 12 is minus. Minus 14 plus 2 is minus. Minus minus gives you plus. A number between this one, let's go with minus 5. Minus 5 plus 12 is plus, but still this is minus. Plus minus gives you minus. Anything greater than minus 2 gives you plus and plus, which is plus. So in this case, I'm required to find the region that it is negative, the region that it is negative. And then it is clear. You can write your final answer. X is greater than minus 12 and it is less than minus 2. Okay, hands up who got these three answers. This, and this one you got it. Okay, so now, like, is it clear the reason why you should make one side 0? එක පැත්තක් 0 කරන්න ඕන reason එක තේරෙනවද? Let's say we are having 1 here. This is not a way that you can find whether this is less than 1 or greater than 1. එහෙම හොයන්න බෑ. We only consider the sign of this. What we can say, whether this is positive or negative, that's all. Using this, what I can say is whether this is positive or negative. So that's why we have to keep one side 0. Then it is either we should consider this is negative or positive. If it is something like 1, there's no any way that you can find whether this expression is less than 1 or greater than 1. That I don't know. So from here, we only get the sign, whether it is positive or negative. Clear? So that's why we need to make one side 0. Then it is clearly either we have to find it, is it the positive range or the negative range. Clear? No? Okay, now to question number 7 and 8. Question number 7 and 8. If you didn't get the inequalities tuned for now, just share with a friend, because next week I'll be giving you a complete algebra tute which consists of more than 8 lessons. Inequalities, recurring decimals, partial fractions, basic mathematical concepts, modulus graph, functions, and logarithms. So that tute consists of all the algebraic lessons that we have, this basic algebra. To question number 7 and 8. If there's anything unclear, you should ask me. Like there's no reason to be shy or anything. ලැජ්ජ වෙන හේතුවක් නැහැ. ඇවිල්ලා තියෙන ඉගෙන ගන්න මම ඉන්නේ උගන්නන්න. So even though you think that is a small thing, it might not be a small thing. So better to ask and clear. Like if I see the phases, like when I look at your phases and emotions, if I understood that you couldn't understand it, or if there's a doubt, then I might come and ask whether all is good. Even though like I don't come, like if there's a problem, ask it. The small things you need to clear them. We have to be crystal clear about these stuff. Okay, question number 7 is x squared minus x is greater than 0. So I told you the, like after making this 0, we have to completely factorize this. No? So when you factorize this, it's x into x minus 1. And then I told you to mark the values that make each term or factor 0. No? This becomes 0 when x equals 1. And now tell me, what is the value that makes this 0? What is the value that makes this 0? X becomes 0 when x is equal to 0. So how did you get this 1? Is x minus 1 is equal to 0, then x is equal to 1. No? So that is how we get this 1. No? So if you write the same thing to x, what can you write? X is equal to 0. That's all. That's all you can write. Clear? So what makes this 0 is x is 0. And then take the sign. If it is a minus, if you go with minus 1, minus is plus. If it is 0.5 half, this is plus, but this is still minus, it's minus. Anything more than 1 gives you plus, which is plus. And then I'm required to find which is positive, this region and this region, which means you can write the answer that x is less than 0 or x is greater than 1. Final answer is x is less than 0 or x is greater than 1. Okay, question number 8. Question number 8. It's x cube is greater than x. So what is the first step that I told you under sine curve method is that you need to take all the terms to one side. ඔක්කොම එක පැත්තකට ගන්න. You need to take all the terms one side. X cube minus x is greater than 0. Then completely factorize. I'm taking x out, x squared minus 1. And then you have to completely factorize this, x minus 1 and x plus 1. And now it is clear. Mark every value that makes this 0. This becomes 0 at 0. This becomes 0 at 1. And this becomes 0 at minus 1. Same drill. Only difference is we are having three terms. So think of a number, same drill. Even though the number of factors increase, nothing change. Same drill. Think of a number less than minus 1. Let's go with minus 2. This is minus. Minus 1 is minus. And even this is minus. Take a number like minus 0.5. Minus half. Okay? Minus half. This is minus. Minus is again minus. But minus half plus 1 is plus. And then take plus half. This is plus. Half minus 1 is still minus. Half plus 1 is anyways plus. And if you take a number that is greater than 1, all these will be plus, plus, and plus. And now look at the sign. So this gives you negative. So when you are finding the sign, only consider about these negative signs. So here, how do you get this sign? කොහොමද මේක normally sign එක ගන්නෙ? Negative into negative is positive. Positive into negative is negative. So that's how you say it. So what I say in this case, how do you take the sign? Negative into negative is positive. Positive into positive is again positive. But when you're taking the sign, you don't have to consider about the positive values. Sign එක ගත්තී positive කට්ටිය ගන්න ඕනේ නැහැ. Look at what is the reason? මෙතන even though there is a positive here or not. Now tell me, even though there is a positive here or not, what will be the sign? Here, what is the sign? It's positive. So here it's positive. Even though there is a positive, there won't be any sign change. No. There won't be any sign change. Because when we multiply a positive number by a positive number, I'm getting a positive value. If I multiply a negative number by a positive number, I again get a negative value. I'm getting the same one. So when you are checking the sign, just check the negative marks. 3 negative marks means negative, or 2 negative marks means positive. 1 negative mark means negative, all positive means positive. So that is the best way. You don't have to say like O levels zoology, you don't have to go in this way. Positive into negative is negative, negative into positive is negative. No, you don't have to do that. Only just check the negative marks. Clear? Because the negative marks is responsible of the sign. When we have odd number of negative marks, it's negative. When we have even number of negative marks, it's positive. So I'm writing this is negative, positive, negative, and positive. And there we have to find the region that is positive. It's positive in this region and this region. So it's positive in these two regions. X is greater than minus 1, less than 0, or x is greater than 1. Clear. So even though you're having 2, 3 factors, 4 factors, 5 factors, any number of factors, any number of any type of linear, non-linear inequality, you can do this in this way. Clear? Hands up who understood this one. Question number 8. Hands up who understood. Okay, now finish the work. There's one thing that I need to discuss in this question. If you have taken the answer alone, that's good. But when I'm asking you to do the next question, I need the entire class to get the answers. Okay. Okay, now my question is this way. Like, let's say someone is doing in this way. I'm canceling this x. Listen. I'm canceling this x. And I'm getting that x squared is greater than 1. and then I'm taking this side. So I have taken a simplified version of the inequality. So previously what we had was x cube is greater than x, and I have cancelled x and x, and then I have taken a simplified version of this. Okay, hands up if you are telling this is correct. What he have done is correct. No one. මොන හරි එකකට උස්සන්න ඕනේ ඈ. Okay. Hands up if you are telling this is wrong. Okay, now tell me, hands up, if you know what is the, okay, this is wrong. I admit this is wrong. Now hands up, if you can properly say what is the error here. Only one, two. What is the error? Yeah, that is one error. Same reason. That is one error because if you can remember last week I told, not last week, few weeks back, I told you like when we are having something like a squared is equal to a, I told you that we can't cancel because like canceling means we are dividing by x. No? So we can't divide by a without knowing that that is not equal to 0. So that is one error. So that is one error that we have done. Okay. So forget about that. Okay, let's assume that x is not equal to 0. Let's assume that x is not equal to 0. So like let's assume in the question they have given that x is not equal to 0. Okay, now try to figure out error here. Yeah. So the other error here, what is that what we do by this cancelling, there's no any thing in maths called cutting or cancelling. So what is the mathematical operation here? It's division. So what I do here is I divide both sides by x. And I get that x squared is greater than 1. Okay. So now tell me what is the rule you know about the division of inequality? Can we divide inequality by any number? Can or can't? Tell me what is the rule that we know about the division of inequality? Can we divide or can't? We can divide. We can divide, but there's only one thing. If we are dividing by a positive number, the sign remain unchanged. But if we are dividing by a negative number, the sign changes. So that is only the rule that I know. But here I have divided by x. So what is the sign of x? X is a variable. What is the sign of x? That we don't know. So the main mathematical error that we do here is that we have divided the inequality by a term with an unknown sign. You can't do that. ඒක කරන්න බෑ. ඇයි කරන්න බැරි? If this is positive, this is correct, I admit. If it is positive, I have divided by positive value, the inequality remain unchanged. But what if this is a negative one? What if this is a negative one? It's wrong. Because if x is negative, this changes. So that means keep in mind, you can't divide or multiply an inequality by a term with an unknown sign. So if you don't know a sign, you can't multiply or divide. But yeah, you can't do that. Simply, when there is something related to x, you can't multiply or divide because you don't know the value. You don't know the sign. Clear? Okay, so don't do this one like I don't expect that anyone has done in this way. But in case if we have done in this way, it's wrong because in inequalities, an inequality cannot be divided or multiplied by a term that we don't know the sign or by a term with an unknown sign. Okay, write in this way, put a red star mark and write in a red pen. Put a red star mark and write in a red pen. Write in a red pen. An inequality, an inequality, an inequality cannot be multiplied or divided. An inequality cannot be multiplied or divided. Cannot be multiplied or divided with a term, by a term with an unknown sign. by a term with an unknown sign. So in a normal pen, under that right, under that one, right? Therefore, therefore, inequalities cannot be multiplied. Therefore, inequalities cannot be multiplied or divided, or divided by x, by x. Okay. So I'll ask you to do the next question. So the only change is like, let's say we are having this equality mark. So when we have this equality mark, then we have to consider these boundary values. Then we have to consider this boundary value. So then when you are writing your final answers, it should be greater or equal, less or equal, greater or equal. So that is the only difference. Okay. So when we are having an equal mark, because next question we have an equal mark, then we have to consider these boundary values. So when you are writing the final answer, include that equal mark. Clear? Okay, do question number 9. Okay, so first we have to factorize, and the golden rule of factorizing is when you see common terms, take it out. So when you take x out, it's x squared minus 6x plus 8. Then you can factorize this. It's x minus 4 and x minus 2. Mark each value that makes factor 0. Okay, this becomes 0 at 0, this becomes 0 at 2, and this becomes 0 at 4. And then take any value from the region. If you take minus 1, this is minus, and even this is minus. If you take plus 1, this becomes plus, but still the remaining two are minus. And if you take 3, this is plus, this is still minus, and this is now plus. Any value after 4, all three are plus. So here, it's, I told you, don't think about the positive one. When we have odd number of minus, that means it's minus. Even number of minus, that means it's plus. 1 minus is plus, and this is plus. Clear? So then you need to find the range that is greater than 0. It's greater than 0 in this region and in this region. But I told you, if they are asking the equality, consider the boundary values, these values. So even in the final answer, you have to write it. It should be x is greater or equal to 0, less or equal than 2, or x is greater or equal to 4. Then you can get it. X is greater or equal to 4. Okay, question number 9. Hands up who got these two answers. Clear? Okay, good. Okay, now let's see. We are having a question like this in this way. Now listen, silence. X minus 2, x minus 4 over x plus 3. We have to find the region that is greater than 0. Okay, now listen properly. So when I was explaining about the sine curve method, did I mention that we can use this sine curve method only when we are having a product of factors? එහෙම කිව්වද මං කිව්වද අර product of factors දිනනවා නම් විතරයි we can use this sine curve method? No, I didn't mention anything like that. So same thing, even though when you have a division in this way, what you can do the same thing, check whether it has been factorized properly. So it has been factorized, and then same drill, no change. And consider the values that makes this 0. This becomes 0 at 2. This becomes 0 in 4, and this becomes 0 in minus 3. So after that, getting the values, same thing. Think of a number in this region. Sleepy faces, when where? No sleepy faces. No, stay straight. Okay. So think of a number less than minus 3. Let's go with minus 5. This is minus. This is minus, and this is even minus. Think of a number in between this. Let's go with 1. This is minus. This is even minus, this becomes plus. If you consider 3, this is plus, but this is still minus, and this is plus. Anything greater than 4 gives you all is plus. So again, when you are writing the final sign, like don't act like, in which grade do we learn this minus minus plus in 7, 8, 6? In which grade do we learn this minus into minus is plus, minus into plus is? You don't wait till grade 10, 11 to learn those, no? Can't remember, 6 or 7, no? Okay, let's assume it's 8. අර මැද එකක් ගමු 8 වසර කියලා. So you learn this minus minus is plus in grade 8, no? So now when you come to A level, don't repeat it minus minus plus, plus divided by minus minus. No, not in that way. Now we have to be advanced. So when we have 3 minus marks, wherever the minus is, it can be in the numerator, denominator, කොහේ හිටියත්, if it is 3 minus marks, it's minus, that's all. If it is odd number of minus, it's minus. කොහේ හිටියත් කමක් නැහැ. Okay, if it is odd number of minus, it's minus. Even number of minus plus. This is minus and this is plus. So by now, we have done about around 8, 9 questions. You should realize there's a pattern, no? There's a pattern. If the first one is minus, it's minus, plus, minus, plus. So everywhere, like if the first one is minus, it's minus, plus. It's like a battery. So if the first one is plus, it's plus, minus, plus. So every time you can see in almost like every question that we have done, there is a particular pattern. Okay, so there's a pattern, like it acts like a battery, minus, plus, minus, plus. You can't charge it, but it is like the shape of the battery, a plus, minus, plus, minus. Same thing, you are supposed to find the region that is positive. It's positive in this region, and it is positive in this region. Then you have to consider this region, write the answer, x is greater than minus 3 less than 2, or x is greater than 4. Clear? So even when we have a ratio between the factors, you can use this. Okay, write in this way, put a red star mark and write in a normal pen. Write in this way. The sine curve method, the sine curve method can be even applied, can be even applied when the expression or inequality, when the expression or the inequality is a ratio. When the expression or the inequality is a ratio. So when it is a ratio, still you can do this. Okay, then do this example and then do question number 10. First do this example. You don't have to look at the board. Same drill, same drill. So throughout this lesson of solving inequalities, we will be doing the same thing. No difference. Do this alone. Do this question and then do question number 10. You do question number 10, mark the values that make it 0, minus 5, minus 1, and 2. Clear? Okay, then think of any number in these regions. So if I go with minus 7, this is minus. This is even minus. Minus 7 plus 5 is minus. If I go with minus 3, minus 3 minus 2 is minus. Minus 3 plus 1 is minus. And this one is now positive plus. If I go with 1, this is at minus, but this is plus and this is plus. Any value after 2, it becomes plus, 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 all plus. So when we have 3 minus, it's negative, it's minus. 2 negatives, it's plus. 1 negative, it's minus. And all plus means it's positive, no, plus. But here they ask in the region that is greater or equal to 0. which means this region and this region. I told you when there is equality, we have to consider the boundary values, which means x is greater or equal to minus 5 less or equal to minus 1 or x is greater or equal to 2. Clear? So we are supposed to find the region that is greater or equal to 0. You get this value. Okay, hands up who got minus 5, minus 1 and to this value. Okay, now hands up if anyone who wrote a slightly different answer with the same minus 1, minus 5, minus 1 and 2, but only making a small change. Anyone? Okay, so no one is there, no? Okay, so out of the, so this is the fourth class I'm doing this, no, in the two single medium classes and the morning class. There was only one student who did two students in the Wednesday single medium class. So now think of this. Let's take minus 1 and put minus 1 here. What happens? It's 0, no? So when it becomes 0, this entire product becomes 0. That is okay because we have to consider equal 0. No? We have to consider that. So that is okay. And now if we put x equals 2, this becomes 0. When this becomes 0, the entire one becomes 0. No? Clear? Entire one becomes 0. Again, we have to consider the equality. That is okay. But now look, if we consider x equals minus 5, who becomes 0? Who becomes 0? The denominator. So tell me what happens when the denominator becomes 0? When we divide by 0, what happens? It's not, it's not defined in maths. There can't be a 0 in the denominator. So when we are having a denominator, keep in mind, we have to take out that value which makes the denominator 0. Because if x is equal to minus 5, this becomes undefined. If x is equal to minus 5, this becomes undefined. So in this case, always keep in mind, when you are writing this equality, and normally what we do, we consider these border values. We consider the border values. But if there is this denominator, the denominator can't be 0. Then in this case, you have to take out this minus 5. Your final answer should be that x is greater than minus 5, not equal. But here, in all the other terms, there is the equality. Okay. Put a red arrow near this denominator and write this. Put a red arrow near the denominator and write this. If the denominator becomes 0, if the denominator becomes 0, it is not defined in maths. It is not defined in maths. So, killing it it is not defined in maths. Therefore, we need to exclude the values. We need to exclude the values. We need to exclude the values that make the denominator 0. That make the denominator 0. Okay. That means like in this case, we have to exclude this one. So then write your final answer using a red pen. Don't just depict it. Don't just depict it. Just cancel it and write in a red pen that this should be only greater than. And there's a similar question. Do that question even. So Emril first completely factorize it. Then consider the values that make each factor 0. Okay, so first factorize this. So when you factorize, it's minus 1 and minus 12 is x minus 4 and x plus 3. So soon after you have a denominator and you see that they have considered the equal mark, make sure that this is not equal to 0. So x can't be 4 or minus 3. So in the final answers, you are supposed to exclude them because the denominator can't be 0. Consider the number line So when you consider the number line, it's minus 3, 1, and 4. Now think of a value, then you have 4 regions. No. If you go with minus, all will be minus. If you take something like 0, this is minus. When this is minus, this is only plus. After this one, this becomes plus, minus, and plus. And after 4, all becomes plus. So this is minus, plus, minus, and plus. What I require here is to find the region that is negative. So this one less than 0 and this one. Normally, when there's a equal mark, we have to consider the boundary values, but I told you, anyhow, I need to exclude this minus 3, 1, and I need to exclude 4. Then your final answer should be x is less than minus 3, or here there's the equality, x is greater or equal than 1, but less than 4. Clear? It's less than 4. Okay, hands up who got this answer. Nice. Okay. I'll give you 1 minute, drink some water, and if there's anything you can talk. Kata karanna තියෙන කතා කරන්නකෝ. Okay, now to question number 11. Okay, silence. To question number 11. Silence, silence, silence. Okay. To question number 11. X minus 5. Okay, silence. X minus 4 over x plus 6 squared. Okay. So now when you mark the values that makes this 0, it's minus 6 plus 4 and 5. No? Yeah, so these are the values. No? So when you mark it, it's minus 6, 4, 5, and then this. Okay. Okay, but now look what happens here. If you consider any number less than minus 6, let's go with minus 7. This is minus. Minus 7 minus 4 is minus, and again minus 7 plus 6 is minus. I admit, but it is squared. No. So when it is squared, what happens? This becomes plus. No, when it is squared, it becomes plus. So there's something different here. Here it's a square. No? So since it's a square, whatever the region we consider, whatever the value we substitute, when we square it, it becomes positive. So when there is a square, complete square here, whatever the region, whatever the value we consider, this denominator becomes positive. So everywhere it's positive, positive, and positive. It's positive in everywhere. In every region is positive. Then only consider about the sign of the numerator, because whatever the happens, this is plus. So if I take a value in this region, let's go with 1. 1 minus 5 is minus, 1 minus 4 is minus. If I take 4.5, 4.5 minus 5 is minus, but 4.5 minus 4 is plus. And then this one, both are plus. Like you take 6, 7, 8, anything, it's plus, plus. So now when you are writing it, you don't have to consider about the denominator, because whatever we have, it's plus, no? It's plus. So here it's clear. It's minus, minus is plus, minus, minus is plus, minus, plus is minus, and plus, plus is plus. But now here, you can see there is a change in the pattern. No? So far, every problem that we did, there was a pattern plus, minus, plus, minus. But here, it's not that way. Plus, plus, minus, plus. So there's a change in the pattern. So what we have to find the range that is negative, it's negative in this region. This is negative in this region. Clear? This is negative in this region. So when we are having this square term, whatever the region we consider, it's plus. You don't have to consider it. Simply, you don't have to consider about its sign. Only consider the numerator sign. Then your answer is x is greater than 4, but it is less than 5. X is greater than 4, but it is less than 5. Clear? Okay, now I want you to write the answer looking at this number line. What is the answer if they have asked the region that this inequality is greater than 0? Now I want you to write the answer looking at this number line. What is the answer if it is greater than 0? Like they have asked whether the region, whether it is like, where is it positive? Okay, write the answer. Write this and write the answer. So I need you to write the answer. If they ask in the region of X, such it's positive. If the region is positive, then I'll just erase this one. Now it is clear the region, it is positive. It's positive in this region. It's positive in this region. And it's positive in this region. Because in all these regions, it's positive. And if I write, okay, now it is clear, but I want to find the region, this is positive. No? It's positive in this region, and this region. And if you mark this in this way, and if you write the answer as x is less than 4, O, O, x is greater than 5. Now what did I do? I mark this region, it's positive. I mark this region. I mark this region. So I'm writing x is less than 4, or x is greater than 5. Okay, hands up who wrote this answer. Okay, like there are half of the class has written this answer. But the issue here is like, can you see there are two regions here? So we mark this region and then we mark this region. So what is the number that is divided in that region? It's -6. So what can you say about -6? What can you say about -6? It's in the it's in the denominator. So if -6 in the denominator, then you can't consider that value. And like, what did you do? You mark two regions, no? You mark two regions, and then you wrote it as one region. එහෙම කරන්න බෑ. Like you are the one who marked this as two regions. And then you are writing it as one region. That is wrong. No? Now if you talk about South Africa, so when the African continent in this way, here you have the which ocean? අපේ වටේ තියෙන මොකද ocean එක? Pork? Indian Ocean. It's the Indian Ocean. So what is the ocean next to this one? What is this ocean? It's the Atlantic Ocean. So you call this place not the Pacific. Pacific in Taveha. Okay, so you call this place in South Africa like Cape Town or Cape of Good Hope, where we consider this Atlantic Ocean and Indian Ocean combined. So even though it is one ocean and it is one ocean, even though you seem like you look like this looks like one ocean, you can't name this as then Indo-Atlantic Ocean. No? It's separate two regions. So the same thing you did here. You marked one region and then you marked another region and then you are naming it as one region. එහෙම කරන්න බෑ. You can't do it that way. Okay, so it's wrong. So clearly there is a -6 here. So if you have, I'm explaining these things because when I just overlook the papers, I see these mistakes. Now let's say when you are writing this answer, so this was the answer. No? It's simple. No? So why did I ask you to write the other side? Because I know students do these mistakes. So I need to make them clear. Clear. Method you can't write it. From here onwards, if you are marking two regions, this is wrong. Mark it, write it as two regions. So how can you write it as two regions? How can you write it as two regions? This is x is less than -6, or x is greater than -6, less than 4, or x is greater than 5. So you have to write this as two regions, 1, 2, and 3. Clear? Hands up who wrote this one? Good. Okay, if you have written in this way, put it wrong. Don't tip X, don't tip X the answers. It's okay, it's your maths book. Not a chemistry book that you need to have a crystal clear, clean book. Every problem, every yeah, problem you solve, one time you get the answer. Yeah. Even though you get the answer now, when you are going time, when we are moving on with other lessons, it might be totally like you're cutting the answer, don't get in the answer. That happens, huh? So like when you get a wrong answer, don't use this tip X and change it. Just cut it, write the correct answer. This is wrong. Okay, because I drew this world map. So when like these days like we are having this these days not we are having like we are Iran Israel war. No? So we think that Iran is so far away of us. No, have you seen in the world map where Iran is? Have you seen in the world map where Iran is? So what is the country above us? Maldives? India. Okay, above us is India. No? So above is Sri Lanka is here. Here we have India. So what is in the left border of India? What is in the left border in India? It's it's Pakistan. That you know. No? So if you have India here, Maru, okay. You did history, no? You have still you get 12 marks for the world map and 8 marks for the Sri Lankan map, no? Then not the map again, not the. You don't you get no. So when you have India, this and this is Sri Lanka. So the country here is Pakistan, and the country next to Pakistan is Iran. Okay, so it is not so far away. So far is like more than 2,000 kilometers, but like not even more than 2,000 kilometers. But still, like it is like neighboring countries. කිව්වොත් අල්ලපු ගෙදරට අල්ලපු ගෙදර අල්ලපු ගෙදර. But ළඟ ඉන්නේ, not Iran is like somewhere not like here. It's like this is India, and this is Pakistan, and then here it's Iran, and above between Pakistan and Iran is where we got Afghanistan. Clear? So it's not far away, yeah. Okay, then do question number 12. Silence, silence, silence. Question number 12. Hurry, okay. Silence. Silence, silence. Silence, silence. Do the next one. Question number 12, 12. Next one. Stop talking. Weda. Question number 12. Okay, so same thing. Consider the values that makes these factors 0. This becomes 0 at minus 12. Silence. This becomes 0 at 4 and 6. And whatever the value you consider, you don't have to consider about the denominator. So even though you don't write the denominator, that is okay. Because let's see, like even you write the denominator, it's positive. And I know there's no any change of the sign when you divide by positive. No, when you divide someone by a positive value, there's no any change of the sign. So even when you don't mention this divided by positive, that's okay. You can only go with the numerator. Minus 14 is minus and minus. If you have 1, it's still minus, but this is plus. If you have 2, oh no, sorry, 4 and 6, it's 5. This is still minus, and this is plus. Anything after 6 gives you plus. So this region, it's plus. This is its minus, it's minus, and this is its plus. Okay. Okay, then you're supposed to, so you can see because of these square terms, the pattern changes. So every time when there is a square terms in this way, the pattern changes. See? Plus, minus, minus, plus. Not that battery plus, minus, plus, minus. You are required to find the range where this is positive. Okay, this one and this one. Okay, so this is the range that this is positive. which means the final answer is x is less than minus 12 or x is greater than 6. Okay, hands up who got x is less than minus 12 or x is greater than 6. Okay, now write the same one which is less than 0, the same inequality. Looking at the same number line. So I need the entire class to get this properly. Yeah, calling where the current part. Don't do the previous mistake. The range that is less than 0. Okay, same thing. It becomes negative. It's two ranges. Don't combine the two ranges and write that x is in between minus 12 and 6. It's clearly two regions, this region and this region, and it is divided by, separated by 4. Because we know, like when 4 is in the denominator, x is not equal to 4. When 4 is in the denominator, x is not equal to 4. Clear? Okay, then you have to write the answer. Write it as two regions. X is greater than minus 12 less than 4 or greater than 4 less than 6. Greater than 4 less than 6. Okay. Hands up who wrote this answer properly. Okay. 2, 17 and 18. Silence. Question number 17 and 18. Katana evade karante. Katana Pasha is there කියන බෑ. When I ask you to do something, do it. That's all. Can't repeat it. Especially in 2027 class, can't repeat those. Okay, so this one is the first step, not the first step. The second step is to factorize this. No. So I told you what is like the golden rule of factorizing. When you see common terms, you have to take it out. So there are two ways you can factorize this. Either you can expand this and simplify and again factorize. If not, you can simply take out this x minus 1 factor. No? Because the simple, the basic step of factorizing is if you see any common terms, take them out. So I can take this x minus 1 out. And then this becomes 2 times x minus 1. If you pull this out, only minus 3 is remaining. Clear? Got it? If not, you can simplify and get the same answer, I admit. So x minus 1 or 2x minus 2 minus 3. Then I get that x minus 1 times 2x minus 5 is greater or equal to 0. A same drill, take a number line. This becomes 0 when x equals 1. This becomes 0 when x equals 5 over 2. So how do you get this 5 over 2? It's basically you have to make it equal to 0. Make this factor equal to 0. So x is equal to 5 over 2. Clear? Okay, then think of a number less than 1. Let's say minus 1, minus, and even this is minus. Think of a number in between this. Let's go with 2. 2 minus 1 is plus, but still this is minus. Anything greater than this gives you plus. And we are supposed to find the region that this is positive. Okay, this is positive, this is negative, and this is positive. Okay. Okay, then this one, we need to get this region. The boundaries are considered because there's this equal mark and this one. Normal question, not a hard one. So x is less or equal to 1 or x is greater or equal to 5 over 2. X is less, oh, sorry, x is greater or equal to 5 over 2. Okay. And then this one, same thing, like, but I know when there's a square, we know that it doesn't change the sign. Like there's a small difference in the pattern. So if you take the number line, it's minus 4, minus 2, and 3. And then consider any value in this range. This is minus and minus, but even though whatever the region you consider, whatever the sign, whatever the value you substitute, this x plus 2 squared will be plus, 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 and plus. The x plus 1 will be plus. All are plus. So only the change is with the remaining one. If you put minus 3, this is plus, but this is at minus. And if you put plus 1, this is plus, this is still minus. And anything more than 3, all are plus, which means don't consider the positive, just two negatives is plus, one negative is minus, one negative is minus, and three negatives, it's plus. Answer is greater than 0, so mark the region that is greater than 0. So this is a normal one. Comparing to the things we have done, these are easy questions, so no inequality. I get the answer x is less than minus 4 or x is greater than 3. Clear? Okay, hands up who got this answer to question number 17 and this answer to question number 18. Got it? Okay, good. So I'll give 1 minute. If there's anything to complete, you can complete these two. And let's move on to the next type. Okay, write it this way. Using a black pen, write note. Using a black pen, write note. And in front of that, using a red pen, write this. Write this. Inequalities consist of inequalities consist of factors that are not equal to zero. Inequalities consist in factors that are not equal to zero. Inequalities consist in factors that are not equal to zero. Okay, now look at this. Okay, now look at this. The last part under this section, solving inequalities, last part. So if I consider this inequality that x minus 1 into x squared plus 1 is greater than 0, I'm supposed to solve this inequality. Sit properly, okay. Back straight. Don't say like in PVR ke wag par me minne. Okay. No sleepy faces, no. Okay, all good. So here, so what do we do here normally is we take this number line and mark the values that each factor is equal to 0 when they mark the values that makes each factor 0. So this becomes 0 at x equals 1. And if you try to find the value that makes this 0, look what happens. X squared plus 1 is equal to 0. X squared is equal to minus 1. So x is equal to root minus 1. We discuss about imaginary numbers, like real numbers and imaginary. So this is not a real number. You can't just mark it here and show, okay, this is root 1 minus root 1. That is wrong. So here, look at the topic. The topic I have given, when the inequality consists of a factor that is not equal to 0. So simply, this one can't be equal to 0. So then when it is not equal to 0, there's no any way that you can mark it. No. There's no any way that you can mark it on the number line, because we are marking on the number line the numbers that makes these factors 0. No. Clear? So that is what we are marking in the number line. But this case, we can't mark a value for x that makes this 0. Hands up if that point is clear, what I just mentioned. Is that clear? We can't mark a point here. Clear? Okay, we can't mark a value of x that makes this 0. Okay. So in that case, what we have to do, just forget about that one, because look at this. The reason why you can't make this equal to 0, what can you say about x squared? Okay, now tell me, what can you say about x squared? A square term. Square term. It's always positive, no? It's always greater than 0. But it can be equal to 0, no? I need interaction him back. So many malagi gila again. Malagi the nigger. How the verla the nigger manghana again. I need the interaction. It's hard to do. Hard to do. Like hard to continue, especially when we are doing I'm doing this part for the fourth time. Twice in the single medium class and one in the morning class. So it's like a repetition. So like I feel like an automated robot if I don't get a proper human interaction. Clear? Okay. Now tell me we have x squared. X squared is always positive, but it can be zero. No? Why it can be zero? Because when you square zero, it's it's zero. So x squared is not greater than zero. It's greater than O equal to zero. So when it is x squared, it's greater or equal to zero. That is clear. Now I'm talking about x squared plus 1. So x squared is greater than 0, greater or equal to 0. Even though this is equal to 0, there is a plus 1. No. There is a plus 1. No. So x squared, I admit it is equal to 0, greater or equal to 0. But again, what is the reason this is equal to 0? So tell me, I need answers. I will be individually asking questions. If not, okay, tell me, what is the reason that we are putting this equal mark? If we consider the square of 0, it's 0. So now if I write x square plus 1, this is always less than, greater or equal to 0. No? Even when it is equal to 0, we are having this plus 1. No? We are having this plus 1, which means, what can you say about this one? It's greater than 0. No equal mark. මොකද මේක බින්දුව වෙන්න පුළුවන්. මේක මෙයා බින්දුව වුණත් ප්ලස් 1 තියෙනවනේ. අයිතොර ප්ලස් 1 තියෙනවා නම් ඒක බින්දුව වෙන්න බෑ. තේරුණාද? Understood? තේරුම්? Okay. So x squared can be 0, but x squared plus 1 can't be 0. It's greater than 0. So here, I told you the issue that you are having, you don't know about this one. No. So whatever happens here, this is a positive number. So you don't have to consider about the sign of it. Just forget about it and work with the remaining factors because you know that is positive for sure. So when there is someone that you can't furthermore factorize or you can't make it 0, so you can't find a value that makes it 0, forget about it and do the remaining stuff. So when x is less than 1, this becomes minus. When x is greater than 1, this becomes plus. Only consider about that one. Because whatever the value it takes, you can see this x squared plus 1 is always positive. Whatever the region, whatever the value we substitute, x squared plus 1 is always positive. So when there is a term that cannot be equal to 0 or cannot be furthermore factorized, forget about it. Show that it is positive. It is clear it's positive. Just work with the remaining stuff. So here, it's greater than 0. I need to write the answer that it is greater than 0. X is greater than 0. Only work with the remaining stuff. Clear? Okay, so when you're having a factor like this, it is clear it's positive. So forget about that. Work with the remaining factors. Okay, write in this way. Write in this way. When the inequality consists of a factor, when the inequality consists of a factor, when the inequality consists of a factor that cannot be equal to 0, that cannot be equal to 0, and cannot be further factorized, cannot be further factorized, continue the sine curve method, continue the sine curve method using the remaining factors. Continue the sine curve method using the remaining factors. Using the remaining factors. Okay. So why do I, like, what makes me that I can forget about this one and continue with the remaining factors is because this is positive. That is the reason. මේක positive නෙමෙයි නම් මේක අමතක කළාට ගන්න හදන්න පුළුවන්ද? If this is not positive, can you forget this and continue the work? You can't do it that way. But what gives you the freedom to forget about this or keep this away and continue with the remaining factors? It's because this is positive. It's because this is positive. Okay, then write this one, x minus 1, x squared plus 1. X minus 1 and x squared plus 1 is greater than 0. Show that it is positive. Show that it is positive. So show that it is positive. And near this factor, put a red arrow and write in a normal pen. Put a red arrow and write in a normal pen. Write in a normal pen. Since this factor is positive, since this factor is positive, since this factor is positive, we can only we can consider, not only we can consider the sign of the remaining factors. We can consider the sign of the remaining factors. We can consider the sign of the remaining factors. Okay. Then do this and do question number 23. Do this one and do question number 23. After this one, do question number 23. Get the answers. I need the entire class to get answers for that one. When you have that x squared plus 1, forget about that. Show that it is positive and then forget about it. Write the answer to the question which is in the board. There's the answer I have been given. This one, mark the remaining factors minus 3, minus 1 and 2. So since this is positive, you can forget about it and it doesn't become 0. No. There's no value that makes it 0. No real value that makes it 0. Then you don't have to think about it even. Just go with the remaining stuff because it's positive. No, it gives you the freedom to work with the remaining factors. Because whatever the sign the remaining factors got, it will be the same sign when you multiply by positive. So that's why we don't have to consider whatever the sign the remaining factors got, it will be the same when we multiply it by positive. So when it is minus 3, this is minus. This is even minus and minus. If you want, you can write this plus here, but no change. Clear? If you want, you can write. I only consider the last sign. I only want the last sign. If you put minus 2, it's minus. Here it's minus, but minus through plus 3 is plus 1. If I go plus 1, it's plus. This is 8 minus, this is plus. Anything greater than 2, all are plus. But if you want to write this x squared plus 1 plus, you just write it, but no difference. I only care the final sign. A 3 minus means whatever the way it has been located, whether it is in the numerator or denominator. If it is 3 minus, it's minus. It's minus. This one, it's plus. This one, minus. And last one is plus. And you're supposed to find the region that is positive. It's positive in this region. And it's positive in this region. It's positive in this region. And it's positive in this region. Clear? Derive the final answer. It's x is greater than minus 3 less than minus 1 or x is greater than 2. So x is greater than minus 3 less than minus 1 or it's greater than 2. Okay, hands up who got this answer. Question number 23. Everyone got in? Hands up. Okay. take a break and come by 5:30. Okay. Okay, now listen. So in the previous one, now since silence, okay. In the previous one, I told you when let's say this x and y are both real numbers. So we know this notation. Last week we learned about this notation. Both x and y are real numbers. So when x and y are real numbers, if I just consider x squared, it's greater or equal to 0. Because every time keep in mind when we are writing a square can be 0. There is a possibility that a square can be 0. And even if I write x squared plus y squared, still this is equal or greater than 0 because there is a possibility that this is becoming 0 and this is becoming 0. So when this is even 0, this is even 0, it can be 0. So there is a possibility that x squared plus y squared is equal to 0. Clear? Hands up. Hands up. Let me clear. Is it clear? Hands up if that is clear. Okay, so when we have x squared, okay, silence. When we have x squared and y squared, there is a possibility that this one becomes 0 and this one becomes 0. That means if this is 0 and this is 0, even though it's an addition of two squares, there is a possibility it's becoming 0. But what I mentioned previously, when we have something like x squared plus 1, this can be 0, that is true. But even though this can be 0, even when this is 0, there is this plus 1. So x squared, something like x squared plus 1, x squared plus 2, it can't be equal to 0. No, it's wrong. It should be every time, it should be greater than 0. Because like since like at this lowest one, even when this is 0, since we are having a plus 1, it should be greater than 0. Clear that part? Because we will be using this from here onwards, and when this proving of inequalities, we will be using this. So keep in mind, when it is simply a square or only squares, it's equal or greater than 0. But when it is a square plus someone like this, then you can say it's positive. Clear? It's greater than 0, no any equal mark. Okay, towards the right hand side of your book, just in a red pen write note and then write this one towards the right hand side of the book, right corner. Here I have mentioned x and y are real numbers. X, y are real numbers. They are real numbers. Towards the right hand side. Okay. So why this is important? Now let's say let's say we are having an inequality. We need to solve inequality in this way. X minus 2 and I'm having x squared plus 2x plus 3. And I need to find the region that this is less than 0. Listen properly, okay? So here, try to factorize this. You won't be able to factorize this. So there's no any factors. Since there's no any factors, you can't factorize it. You can give a try to factorize, but there's no any way that you can write this. Because for example, the ways that you can make 3 as a product is only 3 into 1. 3 into 1. And since it's plus 3, it should be either minus 1 into minus 3 or plus 1 into plus 3. But in both instances, you know you don't get a plus 2. So there are no factors. So previously, we did a equal one in this way, x minus 1 into x squared plus 1. So I told you in this case, based on this theory, you could have easily say, okay, this is positive. So when this is positive, that gave you the freedom to forget about this, forget about this, that gave you the freedom and forget about this and simply work with this. Okay, so based on this one, since this is positive, it gave you the freedom to forget about that and work with this one. But now the case is like, it's not something like this. No. If it was x squared plus 3, Then it is okay. You can say this is positive. No, x squared plus, I told you x squared plus someone is positive. But now there is a small issue. We are having 2x. And now I need to show that this is positive. Okay. I need to show that this is positive. So this is what we are learning here. When we have to show this type of a quadratic factor is positive, when I'm supposed to show that this type of a quadratic factor is positive, what you should do is you have to complete squares in here. Complete squares is not rocket science, I hope, for everyone, because you completed squares 3 months before. You did it for O levels, to complete in squares, you have done it for O levels, and even you haven't got the results of O levels yet. But some can't even remember. When I look at the phases, I'm just seeing something like complete in squares, complete in squares, kaling ahala borudu dakala diyana. So I see some phases in that way. Hands up, honestly, who can remember complete in squares, the way to complete squares? I'll be giving questions, huh? Hands up, who honestly, who can remember complete in squares? Yeah, so you can't remember, so you can't do in that way. So that's why I'm telling you, your O-level result, I will not know, it will be coming in 2, 3 weeks, not three in 2 weeks, as I saw. So O-level results is independent from your A-level result. That I admit. I told you there are students who I have seen taken, even my friends who got 9A passes in O-levels and then come into science stream subjects and ending up with 3F passes. And meanwhile, I have seen a very few students who are getting a moderate result in O-levels, like 3A passes, 4A passes, but somehow they are working really hard in A-levels and getting 3A passes. I told you there was a, when I was working at MAs, my supervisor, he had 3A passes for O-levels and 3A passes for A-levels. Yeah, 3A passes for O-levels and 3A passes for A-levels. But his 3A passes for O-levels, I think it was maths and something other too. So he was good in maths. He has done maths and he got 3A passes A-level. So it's independent. But that doesn't mean that you can keep everything that you have learned for O-levels and come to A-levels. ඔක්කොම ටික දාලා ඉන්න බෑ. I told you that day you can keep this ගුත්තිල කාව්‍ය ඕක තියලෙන්න අවුලක් නැහැ. පළවෙනි නිමල් ධර්ම සූරියව තියලෙන්න. That's okay. But you have to bring some general maths. So complete in squares, you can't keep then, okay, I did it for O levels, okay, done, chapter close, and I'm coming to A levels. No, there's not this chapter close one. There's a small one, a small connection that we have to bring. Okay, so I'll remind you how to complete squares. So this is how you complete squares. So when you complete squares, when it is x, so I'm not teaching this, I'm reminding it. X squared, it's x. So this is the middle term. Coefficient of the middle term is +2. Take half of it means +1 and square it. So what did I do? I have x squared. So I took x. So this is the coefficient of the middle term. I take half of it, it's 1. So what I have put here additionally, every time what I have put here additionally is the square of this one. So here it's 1. I have put the square of 1 additionally. So then take it out, -1. So this is simply completing squares. What you have to do, x squared, it becomes x. Here the coefficient of the middle term is +2. Consider half of it +1 and square it. In this process, every time you are putting the square of this one additionally, then I'm taking it out -1. +3, it's less than 0. Okay. And then I have x -2. I look at this x +1 squared +2. So this is what did I do? I completed squares. Okay. Hope now you reminded, okay, yeah, mataka, this is what we did for completing squares. Hope you remember it. Okay, now the reason, I'll come back to the beginning part. What happened here is I told you in this type of questions, here you can clearly say it's positive. Therefore, it gave you the freedom to individual, like work with this alone. But in this case, you can't say it is positive. You can't say, but now look at this one. It's a square term plus someone. It's a square term plus someone. Okay, now tell me, when it is a square term plus someone, for sure, you can say, this is? Tell me, there's a square term plus someone. For sure, you can say this is positive. Clear? Okay, now, for sure, you can say that this is positive and this doesn't become 0. It doesn't become 0. You can find a value that makes it 0. And now when you complete squares, you can clearly say it's positive, which gives you the freedom to work with only this one. So only consider 2 when it is less than 2. When it is less than 2, this becomes minus. This is plus, you don't have to consider it. And when it is greater than 2, this is plus. This is anyways plus. So even you consider this one or not, that is okay. So this is minus and this is plus. They're asking us the region that it is negative. A negative, so it's negative in this region. So simply, your answer is x is less than 2. Clear? Your answer is x is less than 2. So same drill. The only thing that in here you can clearly say it's positive, but for this purpose, you need to complete squares, bring it to here, and then say when. So every time, like keep things simple. When it is a square plus someone, it's positive. That's all. Okay. When it is a square plus someone, it's positive, greater than 0. When it is a square, when it is a square, greater or equal to 0. When it is a square plus someone, it's greater, not equal, greater than 0. If it is a square plus someone, no, square, simply only the square, it's greater or equal. Clear? Okay, so write in this way, put this question, put in this, put this question, write this first, write this question. Okay, and near this quadratic factor, put a red arrow and write in this way. Put a red arrow and write in this way. To show that this quadratic factor, to show that this quadratic factor is negative, sorry, positive, to show that this quadratic factor is positive, we have to complete squares. We have to complete squares. To show that this quadratic factor is positive, we have to complete squares. We have to complete squares. Okay. Then do this completing squares, and after coming to here, since this is positive, it gives you the freedom to work with the remaining factors. It gives you the freedom to work with the remaining factors. To work with the remaining factors. Okay, then do question number 20. Do question number 20. So when you see a quadratic factor that you can't factorize, silence. When you see a quadratic factor that you can't factorize, just complete squares of it and then show it's positive, then you can forget about it and work with remaining factors. So that's what we have to do. To question number 20. Silence, silence. Okay, so I told you when you have a factor that cannot be factorized, complete squares and show that it is positive. X plus 1, x minus 3. And now complete squares, it's x, silence. Half of 6 is 3. So then I put x plus 3 squares. So I told you every time in completing squares, what you put additionally is the square of this. So reduce it. Minus 3 squared is 9 plus 10. And then I have x plus 1, x minus 3, and then it's x plus 3 squared plus 1. Clear? Which means I told you when it is a square plus 1, for sure it's positive. Okay, when it is a square term plus someone, for sure this is positive. Then you don't have to consider about it, just go with the other two, minus 1 and 3. So when I consider minus 1, even this is, sorry, less than minus 1, this is minus and this is minus. If you want, you can put plus, but there's no any change. If you consider something like 1, this is positive, this is negative. I'm not considering about this one. Anything greater than 3, this is positive, and this is positive. So I haven't considered this mark because since it's positive, there won't be any change. Which means this one it's plus, minus, and this is plus. And the range that we should find is the positive range, which is this one, and which is this one. Okay. So the answer should be x is less than minus 1 or x is greater than 3. Okay, hands up who got x is less than minus 1, no x is greater than 3. Okay, so like every inequality, like we will be, inequality will be solving under nonlinear inequalities. Listen. You can use the sine curve method. So in the sine curve method, what we have to do, you have to mark the values that make that factor 0. So if there are factors like this where you can't make it 0, where this doesn't become 0, and you can't furthermore factorize, just the additional step, complete squares and keep it. That's all. එක වැඩිපුර වැඩ මගේ අනිත් ඔක්කොම ටික same drill. Other every problem that we have solved from the beginning, it's the same drill. There were slight differences when we are having a denominator that can't be equal to 0. Those are like slight differences, but the same drill, again and again, same thing. But a small additional part was added. When we are having a factor like this, just complete squares and keep it, then you can see it's positive. Clear? Hands up if you understood this one, the sine curve method and this entire one properly. Good. Okay, so like we have done so many problems under solving inequalities. So to finish the stuff, just do question number 27, a small one. You did big inequalities, do the small one. 27. Okay, question number 27. 2 over x is greater than 1 over 3. Okay, so here like when you are supposed to solve a equation, what we normally do, we just cross multiply and get the answer x is equal to 6. No? But here you can't cross multiply, okay? Why can't you cross multiply? When you're cross multiplying, you're multiplying by who? You're multiplying by x. You wrote in a red pen that you can't multiply or divide inequality by x. That is wrong. I wrote in a red pen, because I know like when I, like just imagine you are doing so many big questions, complete in squares and all, and when you come to here, you make it wrong. ලොකු ඒවා කරලා මෙතනටදී වැරදි. So what the basic? So what is the first step of sine curve method? First step, make one side 0. Then take this to this side. Then take the common denominator, simplify, it becomes 6 minus x. Same drill. Take a number line. This becomes 0 when x equals 6. This becomes 0 when x equals 0. Clear? You can't just cross multiply and get the answer, okay? So here when you think of a number less, like let's say minus 1, 6 minus minus 1 is plus, but minus is minus. In between, let's say 3, 6 minus 3 is plus, but here it's even plus. Anything greater than 6, let's go like 8, this is minus, this is plus. Hence it is clear that you can get this one is minus, this one is plus, and this one is minus. And you're supposed to get the range that this is positive, this is positive, which means x is greater than 6. Sorry, 0 less than 6. So if you have done this in this way, multiplying by 3 and multiply by x to get the answer that x is less than 6, it's wrong. Huh? You can't do it. Life is not that easy. It used to be easy back then, but now life is not easy, okay? So you can't do this. It's wrong because in this case, you are multiplying the inequality by x, which is mathematically wrong. Okay. Then finish stuff. Do question number 28. Do question number 28 and finish the work. Okay, same thing when you have a number in the like any term in the other side, you can't do that in this way. You have to bring it to one side and you have to simplify. So take x minus 2 as the common denominator. It's 2x minus 1 minus x minus 2. I have told you when it is a minus, always use brackets. When it is a minus, always use brackets. So 2x minus 1 minus x plus 2 over x minus 2, which means inequality simplifies up to x plus 1. So this inequality, when you simplify, it's up to x plus 1 over x minus 2. So again, when there is a denominator, make sure that the denominator can't be 0. So you have to exclude that answer in your final answer. Take the number line minus 1 and plus 2. I'll just write the answer directly in this range. It becomes plus. This is minus and this is plus. And we are required to find the range. It is negative. Negative. So normally, when there is a equal mark, we have to consider the boundaries. But I know that x can't be equal to 2. X is not equal to 2, which means the final answer, x is greater or equal to minus 1, but it is less than 2. It can't be equal to 2. So question number 28, x is greater or equal to minus 1, but it's less than 2. Okay, hands up who got this answer. Okay, I'll give you like 1 minute, complete the work. Let's do the next section, proving inequalities. Okay, write the main topic, proving inequalities. Proving silence. Okay, write the main topic, proving inequalities. The interesting part, proving inequalities. Proving inequalities. Okay, now listen properly. Sit. Okay, sit properly. No sleepy faces. You have an interval and last part. Okay, so this proving inequalities is an interesting area because this solving inequalities, it's like the same process. No? So once I explain you the process, you have to repeat it again and again. Same thing, but small, like new features are added. When there is a denominator, there's one thing that you have to consider. When there is a factor that you can't factorize, there's one thing that you need to consider. But all overall, when you consider like 90% is the same process, no? Same process. But in this one, this type of questions, this helps to improve your thinking, like the way that you think a problem. So these type of questions, proving inequalities, helps you to improve your thinking and how the way that you approach a problem. So in here, what we have to do is we have to prove that, let's say we have to prove that A is greater than B. We have to should prove that A is greater than B. Okay, listen properly. So after this theoretical part, I'll show a worked example. Then you can easily understand what we have done. So when I'm supposed to show that A is greater than B, what I do, I write an expression like I'll take it as P. You can put any letter. Okay, there's no any like specific letter. You can use any letter. I'm taking an expression and I'm writing in this way. I have A, and what happens when this B comes here? It's minus B, no? So I'm writing an expression such that A minus B. I'm writing an expression. Okay, listen clearly. Okay, I'm right. Like, pay attention. I need to focus. Don't go to different worlds. And when in Sinhala we call it manoparaval. There's no any proper English word. Mental attacks. Oh, yeah. Manobhara means like you are looking at the board, but you are not focused in the board. You are living in a different world, and maybe now you are driving your dream car in that world, and with some like totally different world. I see some students in that way. Like there are some students when I see that the student is not paying attention, I just give him eye contact. Even he's looking at me, but no any zero emotions. Like he's looking at me, but even then, when I'm giving eye contact, zero emotions. What happens? Like, what happens? There should be a emotion or reaction or response? No, nothing at all, because he's not focusing. He's just looking at the board, but he's different in a different world. Like it's so interesting. Like in this class, no, normally in the single medium class, when you do it in the fourth floor, like the class is like full. No? So there are students when I'm giving time to solve a problem, and when I look at the class, there are some students looking at outside, looking at the window, thinking of something, and then they are suddenly like I see the students coming to this world. So in that way, so it's like different worlds. Like it's really interesting. So that's why like when I come, that is one factor that I love. Like normally overall, like what I like is I like to teach students and I like to mentor students. So that is what I do. No, if not personally, like I don't like tuition as a profession, because that is not something that we have a good credibility or reputation in the society. You know, no, that what the reputation these tuition people have in the society. So whenever, like, let's say a policeman like stops me and asks me what do I do, my occupation, I never say that I'm doing tuition. I'm just saying I'm a lawyer. Like saying a lawyer to a policeman is anyways good, no? So like even when I go to someone, go to a function, and if one of my friend is introducing me, I have asked them, okay, if you want to introduce me, tell that I'm a lawyer. If you want, you can add that I'm an engineer. That's all. But I never use this tuition title because I don't personally write it. Tuition කාර්යය කියලා කියන්නේ. Tuition කාර්යය කියලා කියන්නේ. We don't say නීතිඥ කාර්යය කියලා කියන්නේ නැහැ. Lawyer කාර්යය කියන්නේ නැහැ. Engineer කාර්යය කියන්නේ නැහැ. And there was this interesting thread in Facebook, or I can't remember, in Twitter. I think 1 year back in Sri Lanka වෙන ආතල් දේවල් දෙනවනේ social media. හරි දැන් මම දැක්ක ඊයේ දාලා තිබ්බා ඇමරිකාවට ගහන්න ඕන කට්ටිය දවල් එකට අතුරු ගිරියට එන්න කියලා. And there was a Facebook share, Facebook share, post mentioning that people who want to attack America come to Aturugiri by 1 o'clock. And there was like more than 3,000 shares. The post, they have shared that in 3,000. So in this, this thing just came into my mind. This when we are talking about this tuition car, yeah. So there was a thread in that is a good one in Twitter. Someone has posted, we have to bring this culture in Sri Lanka where we use this word karya to some of the occupations. That's bad. For example, the one who takes garbage. Like normally, even you have heard your parents talking him, "Ada kunu karya aave nadda kiyala ne kiyanne, "Ya, kunu karya aave nadda." It's really bad. What if he hears it? He is near there and ada kunu karya nadda kiyala. It's bad. So then the post what they have mentioned, the post they have mentioned is kunu karya kiyanne ba, it's wrong. Kunu geniyana manussaya. It's decent, no? And malu විකුණන එක්කෙනා මාළු කපන එක්කෙනා මාළුකාරයා නෙමෙයි. So you can call it මාළු විකුණන එක්කෙනා. Then that was the thread. So if we have that culture, that is really good, no? The Sri Lankans are like, normally like whatever happens, they are full chill, no? In the even the petrol queues, people used to sing, and then people used to make tea and drinks when people are in this petrol queue in the country. We were enjoying that moment, no? So Sri Lankans is a full chill nation. So in that most like this reputed thread, like it was really good. Even personally, I never talk to someone, even when the people who comes in this garbage lorry come. I used to talk according to the age. I either call them uncle or ayya. I don't care that calling him ayya or at ayya can no. I don't mind it, to be honest. Maybe with the environment that I have brought up, so I call them uncle or ayya. But I don't expect everyone to call uncle or ayya. But kunukara again, So then in that this good thread, this good cultural thread, then people have commented. කුඩු ගහන මිනිස්සයා කුඩුකාරයා කියන්න එපා. අදින්ම කුඩුකාරයෝ කියන්න එපා. උසාවියේ කුඩුකාරයා කියන්නේ එයාට කුඩු ගහන පුද්ගලයා. ඒකට don't use this කාරයා, we can use this ගහන පුද්ගලයා කියලා. So that is what normally like in Sri Lanka, Japan, that just came to my mind when we are talking about tuition karya. So I was okay. So I was talking like the one thing that I'm so enjoying in tuition, when I come to the stage, I see students' reactions. So that is like makes my heart full. Like it, I enjoys it a lot. Like different students. Some students are looking in there, they are living in their dream world. Suddenly come in there, and then I see like students I enjoy. Even I can't stop my laugh. Some students I can see that they are trying their best to like keep awake in this way, and then I say they are pouring water to their hand, and so that's really enjoying. Like that is one part that I enjoy in doing classes. Main is I like to teach. I hope that I can teach in a way that others can understand, and like to mentor students, especially mentor means showing they are a proper path and inspiring them. Other than what is enjoying the responses of students. That is the next level thing. If you one day if you come to this stage and if you look at the students, like this one is a small crowd, but in the up it's like different ways, and I'm enjoying it. So that keeps me energetic. Your responses and your facial expressions. Okay, okay. Listen, come back to the lesson. So here, so when we have this is a minus b. So I told you we have to write this expression. Now listen. Okay, finish. We have to write an expression such that a minus b. And then what you have to do, you have to simplify this. You have to simplify this expression up to a place that you can properly say, okay, this p is greater than 0. I'll show you an example, then you will get it clear. You have to simplify this up to a place that you can clearly say, yes, this is greater than 0. So if you can show that it is greater than 0, now look at this. What can you write? P is a minus b. That means you have shown that a minus b is greater than 0, which means you can say that a is greater than b. Okay, so this is mainly the theoretical process. We consider an expression as a minus b, and then what I do, I have to simplify it, and I should show, and I have to come up to a stage or step that I can clearly say, okay, this p that what I have considered as p is greater than 0. Because if you can show that p is greater than 0, then a minus b is greater than 0. Okay, you can say that a is greater than b. You can say that a is greater than b. Clear? I know like you might say, I didn't get it properly. Never mind, I'll show you a worked example. Okay, now look at this. You are supposed to show that x squared is greater than 2x minus 3. This is what you're supposed to show. Okay, your first question. And then you have to write expression. I'll name it as p. Now it can be any letter. So don't ask me questions like, should we circle it? Should we use P for sure? No, you can use any letter. I'm just using the circle because I am used to that. So if you write this as capital A, is it wrong? It's just you can put any name to that expression. Okay, any name. If your name, put the first letter of your name. Okay, so P. Okay, so what we should write as P is x squared, and we have to write it when this comes this side. Okay, now tell me what happens. What is the term that we got when this comes this side? It's minus 2x plus 3. Clear? It's minus 2x plus 3. So my intention is to show that this is positive. My intention is to show that this is positive. We just discussed when we have a quadratic factor, how can we show that it is positive? We just discussed when I have a quadratic factor, how can we show that that is positive? What is the way? We should complete squares here. Okay. So then complete squares here. Complete squares, when you complete square x minus 1 squared, half of this. So every time we additionally put the square of this. So minus 1 squared is anyway 1. So you have to take it out. Minus 1 plus 3. Now look, I have come up to a stage that px minus 1 squared plus 2. So I told you, when it is a squared plus someone, when it is a squared plus everything connects, when it is a square plus someone, for sure, what can you say? This is greater or equal? No, this is greater than 0. For sure, when it is a square plus someone, you can say that this is greater than 0. So I told you, you need to simplify this and come up to a stage that you can clearly say p is greater than 0. So what is your p? It's x squared minus 2x plus 3 is greater than 0. If you take this to this side, x squared is greater than 2x minus 3. X squared is greater than 2x minus a. So that is how we show it. You bring this to one side, simplify up to a stage that you can clearly say it's 0. Okay, I'll do another example. Example number 2. So I'm supposed to show that x squared is greater than 6x minus 11. Okay, write an expression. Listen this, okay? Write an expression, any letter. Okay, this is, take this to this side, x squared minus 6x plus 11. So when we have to show that a quadratic, when we have to show that a quadratic expression is positive, what we have to do, we have to complete squares. When you complete squares, x minus 3 squared, what we have put here additionally is minus 3 squared, which is plus 9, so it's taken out. Or write it as 10, no difference. So here, it's x minus 3 squared plus 1. So I told you that you have to simplify this expression up to a place that you can clearly say, yes, this is positive. Yes, this is positive. You have shown that m is positive because a square plus someone is positive. A square plus someone is positive. And then what is m? X squared minus 6x plus 10 is greater than 0, which means x squared is greater than 6x minus 10. Okay, so the only way is not complete in squares. There might be different ways, but at the end, your basic intention or target should be to show that this expression is positive. Hands up if you understood this. Okay, so the topic is proving inequalities. Under that, write this. Let's assume. No, not assume. Let's take. Not assume. Cut the word assume. Let's take that we need to prove that we need to prove A is greater than B. Write in a symbol this way: A greater than B. Greater than B. Next line. For this, for this purpose, for this purpose, for this purpose, we need to consider an expression. We need to consider an expression. We need to consider an expression such that such that we need to consider an expression such that, comma, write this: P equals A minus B. P equals A minus B. P equals A minus B. Okay. Okay. Then continue. We have to consider expression such that P equals A minus B. Okay. Then next line. By simplifying this expression, by simplifying this expression, we need to bring it, we need to bring it to a stage, we need to bring it to a stage. We need to bring it to a stage that we can clearly say, that we can clearly say, that we can clearly say, write in a red pen, P is greater than 0. That we can clearly say P is greater than 0. P is greater than 0. Okay, then after that write this, then A minus B is greater than 0. So A is greater than B. Okay. Then do these two examples. Get the help for the example, first example, but when you're doing the second one, do it alone. So the only process is not complete in squares, you will realize when you are doing problems. So somehow I need you to show that the expression is positive. Do these two examples. So only look at the board when you are doing the first one, get used to it, and then do the second one alone. Okay. Okay, now think of a way that how you can show this one. You're supposed to show that a squared plus b squared, silence, is greater or equal than 2ab minus c squared. Okay, give a try. So all these numbers are real numbers. Huh? So real numbers means when you square it, it's positive. Okay, so I'll explain this. The next one, everyone can do it. Okay, now look at this. Like we have to name an expression. We have to take an expression. You know, listen. By taking all these terms to one side, a squared, b squared, minus 2ab plus c squared. Okay, now listen this. Okay, listen clearly. So I'll tell the points that we need to think here. Okay, listen. Now tell me what is my target here? What I'm supposed to do? What am I supposed to do? I need to show this that this is greater or equal to 0 because when the has a equal mark, like here it's greater than, so I need to show it's greater than 0. So my final target is to show that this is greater or equal to 0. මම කොහොම හරි මේක පෙන්වන්න ඕනේ simplify කරලා මේක greater or equal to 0 කියලා. හරි? That is okay. First thing that you need to understand what I'm going to do. Then look at this and look at the terms that are restricting you to say that this is greater than 0. බලන්න මේකේ මොන terms හින්දාද ඔයාට කියන්න බැරි මේක greater than 0 කියලා. Like check because of which terms that the like what are the terms that are restricting you to say that this is greater than 0. A squared, what can you say about a squared? Forget about that equal thing. What can you say about a squared? It's positive. What can you say about b squared? Positive. What can you say about c squared? It's even positive. So what is the term that is restricting you to say that this is positive? It's this minus 2ab. And don't misunderstand. You can't say the sign of this one because this is not, because this is minus. Even when this is plus 2ab, can you say that this is plus? No, ab can be any sign. Ab are variables. AB can be any sign. Clear? Okay, so now try to understand or try to figure out the term that restricts you or stops you by telling that this is greater than 0. Understand? Hands up if you understood that step. And now what you have to do, you need to take out this term in a way that you can say this is positive. මේක අයින් කරන්න ඕනේ ඔයාට කියන්න පුළුවන් විදිහකට මේ ඉන්න එක්කෙනා positive කියලා. You have to take out this term in a mathematical way. නිකන් මකලා දාන්න බෑ. හරිද? In a mathematical way to say okay this is positive. Okay, now look at this. A squared plus b squared minus 2ab. Something familiar, no? Sounds familiar. A squared plus b squared minus 2ab. What is it? A minus b squared. So here It's something familiar. It's a minus b squared. And now look at this. So that's why I told you, you have to take out the term that is restricting you in a way that you can say it is positive. And now look what happens. You know that a squared is positive. You know b squared is positive, but you don't know about minus 2ab. That is okay. When you combine these three, you get a minus b squared. Tell me, what can you say about a minus b squared? It's a square. So if a minus b is a square, what can you say? For sure it is greater or equal to 0. Clear? So we have to come up to a position where you can clearly say, okay, this is even greater or equal to 0. C squared is even greater or equal to 0. So when you add two greater or equal to 0 terms, it's even greater or equal to 0. Simply when you add two positive numbers, it's positive. Positive then එකතු කරාම positive. But there is this equality in බිඳුව වෙන්න පුළුවන්. So when it is 0, it can be 0. Okay, then after coming to this place, you can say clear, okay, then what is m? A squared plus b squared minus 2ab is minus 2ab plus c squared is greater or equal to 0. So here we need to simplify the terms that restrict us by telling that this is a positive one. This is positive one. You have to simplify those terms. Okay, complete this, and if you understood it, do this one. If you understood this properly, do this one. Q4, if you do this, it's good. P squared plus Q squared silence is greater or equal than 2PR minus R squared minus 1 is greater than 2PR minus R squared minus 1. Same thing, same drill. Okay, this one I need answers. You can take it easily. Same drill. Same drill. Take expression. Let's name it as M. P squared, Q squared. Take this to this side. Minus 2PR plus R squared plus 1. Okay, now look at this and tell me what are the terms that are restricting you to say that this is positive. P squared. Is it okay or not? No worries. Okay? No, it is not restricting. Q squared? No. R squared? Minus 2PR is a problem here. What about plus 1? Plus 1 is plus 1? No. It's positive? No, you don't have to worry about plus 1. So here you don't have to worry at all. So here the problem that matters is minus 2PR. Then you can see a connection P squared minus 2PR and R squared. And then you can write P squared minus 2PR plus R squared, Q squared plus 1. Those two are okay. So here, this is the term that was restricting you. So you can write it as P minus R squared. Okay, now you have come to a stage that this is equal to P minus R squared plus Q squared plus 1. Okay, now what can you say? These are square terms. I told you square terms are anyways positive. Okay, now an important thing. What can you say about M here? Is it greater than 0 or greater or equal than 0? Hands up if you are telling this is greater than 0. Hands up if you are telling this is greater or equal to 0. So what is the reason that takes out the equal mark? Plus 1. Clear? So when there are squares and plus 1, it's greater than 0. Okay, that's why even the question says it's greater than 0. And then what is MP squared plus Q squared minus 2PR plus R squared plus 1 is greater than 0. P squared plus Q squared is greater than 2PR minus R squared minus 1. Clear? Got it? No? Okay, then do the first two questions in the next page of the tute. Question number 2. First two questions. First two questions. Silence, silence. It's really easy with the questions that we have done already. Yeah? So brings your level down to really easy questions. When comparing the questions that we have done, these are really easy. Okay, so question number 1 is you are supposed to show that a squared b squared is greater or equal to this. So consider expression this is equal to a squared b squared minus 2ab. So really easy when comparing the questions that you have already done. So this is a minus b squared. Yeah, this is a minus b squared. So if you have come to this stage that p is equal to directly to a square, p is equal directly to a square, and I know a square is always greater or equal to 0. So simply you can take the answer that what is p? A squared plus b squared minus 2ab is greater or equal to 0, which gives you that a squared plus b squared is equal to 2ab. Okay. Okay, hands up who got this one. Didn't. So then the other one is even the same, you end up in the same place. So this is 2 times a squared plus b squared is greater or equal to a plus b squared. No? So even when you simplify, you end up in the same place. M is equal to 2 times a squared plus b squared minus a plus b squared. So here 2a squared 2b squared minus a squared plus 2ab plus b squared. So when you simplify this, it's 2a squared 2b squared minus a squared minus 2ab and minus b squared. So it is clear you even here end up at the same place, a squared plus b squared minus 2ab, which is equal to a minus b squared. So when you can clearly say, okay, this is a square, which means it is greater or equal to 0, then that is okay. So this is greater than 0, which means greater or equal to 0. M is greater or equal to 0. You can write the final answer. What is M? 2 times a squared plus b squared minus a plus b squared. Then you get the answer. 2 times a squared plus b squared is greater or equal to a plus b squared. Clear? Okay, this is what to get the same thing. Okay, so now I'll give you a problem like where you have to think a bit, think a bit. So we did this. So name the questions that I'm giving as Q1, Q2. So then OS you can write this as tut. So we did 4 questions. Now I need you to show that a squared plus 2b squared is equal or greater than 2ab. Okay, a small part you have, there's a thing. So I'll give you time. I need everyone to think and do this. If you have done, just keep your hands raised up. I'll just come and check it. So that's why I told you this is not a process. So these are the questions that you need to smallly, like gradually improve your thinking. Same process that take into one side and all, but at the end when you are supposed to show that it is positive, you need some thinking part. So if you have completed, like keep your hands raised, I'll just come and check it. Silence and think. Now when I give you time, so that's why I'm giving you time. If I won't give you time, like you won't be able to think. ගෙදර ගිහලා හිතන්නේ නැහැනේ කොහොම. So hands up if you're taken the answer. Like if I didn't check your book, keep your hands up. Okay. So now this is the thing here. Now listen, silence. So good. So many boys have done it, but only two girls I saw. Maria girls are. There should be more because I more than 10 to 15 boys have done it. I didn't expect that much to do. Really good that you have done it, but you should do more. Huh? A small thing. Let's see. So this is how you think it. Okay. Now look at this. What you have is this one. You know, write this expression. It's m is a squared plus 2b squared minus 2ab. Okay, a small thing that I'll tell you to think. Okay, this would have been familiar. This would have been familiar. This is a squared plus 2b squared minus 2ab. So what is the term that is restricting you to show that this is positive is this term. So I know like how I exclude, how do I take out these minus 2ab terms by putting it inside a square. No? So in every of this problem, how did I take out this minus 2ab minus 2pr terms by putting it inside a square. No? So look at this everyone, look at this here, look at this one. How did I take out this minus 2ab? How did I take it out? I took it inside this a minus b squared. How did I take out this minus 2pr? I put it inside this one. And so every one that we have done, we have put it inside a square. Now you tell me, this would have been familiar if it was a squared minus 2ab plus b squared. This would have been familiar if this is b squared. No. Then write it. Okay, you are the one who told me, sir, this would have been familiar if this is b squared. Okay, then write it b squared and keep the remaining b squared away because b squared is anyway positive. B squared is anyway positive. You don't have to think about it. Okay, now here's your familiar term a minus b squared. Clear? So you have written that m is equal to a minus b squared plus b squared. We have the addition of two squares. We have the addition of two squares. This is greater or equal to 0 and even this is greater and equal to 0. So when it is a square, you don't have to worry about it. So m is greater or equal to 0. So what is m? A squared 2b squared minus 2ab. Clear? So a squared plus 2b squared is greater or equal to 2ab. Clear? So like always think, okay, this would have been familiar if I got this. Okay, let's do one more and then finish the work. I need the entire class to get the answer for this one. If you have done it, good. But this one, I need everyone to get the answer. Last question that we will be doing today. So let's name it as Q5. Silence, silence, silence. Silence, Q6. Silence, silence. Silence, silence. So do this one, Q6. It's 3a squared, silence, plus 2c squared is greater than 2ac minus 4. Okay, show this. Same rule, if you are telling me, so it would have been familiar if if it was in this way, so make it familiar. That's all. Make it familiar. Okay, take this expression, let's name it as P. Silence, silence. 3a squared, 2c squared minus 2ac plus 4. Like when you have something like plus 4, you don't have to worry about him. Okay, because there's no any harm, no. Anyways, positive. No. Okay, now same drill, you know. How did you take out these minus 2ac terms? By putting it inside a square? No? But for that purpose, I need a minus c squared. So I don't want 3a squares and I don't want 2c squared. Just take 1a squared minus 2ac and plus c squared. So you can collectively consider that this is a minus c squared. And then write the remaining 2a squares, write the remaining c squared, and write the 4. So out of these 3a squares, I only have taken 1. Out of these two, I only have taken 1. Which means this gives you a minus c squared. So when you come to a position that silence, silence, silence. A minus c squared, 2a squared, c squared plus 4. So here you can say all these squares, this part, all squares are equal or greater than 4, sorry, 0. But even though it's equal to 0, we are having this plus 4. No? So when we are having a plus sum 1, then make sure you write this is greater than 0, not equal. Okay, so when you're having plus sum 1. Then 3a squared plus 2c squared minus 2ac plus 4 is greater than 0, is greater than 2ac minus 4. Okay, hands up who got this answer, the last one, everyone got it? Good. Okay, so before getting ready to go, let's listen this properly. Wait, wait. So I could කලින් ලෑස්තිවට කලින් යන්න බෑ මම යවනකම් ඉන්න ඕනේ. Wait. So listen. Okay, then get ready quickly, get ready. Okay. Okay, now listen, 1 minute. Hands up. Wait. Hands up who came to this Polynomials live YouTube session on Sunday live, or either you watched the recording. Hands up who came live. Okay, who watched the recording or joined live. Hands up who knows that we had a YouTube live session on Sunday. Okay, so listen this properly. So from here after, like when I do a YouTube session, I need everyone, if the time is convenient and you are available, you join online. If not, I need everyone to complete the recording and come to the class next week. Since this is the okay. So since this is the first YouTube live session we did, I didn't check it today, but next week make sure to bring the work that I have done in this polynomials YouTube live session. Not only the work that I have done in the session, I need, like I told you, after completing question number 41, I told you, okay, 42, 43 is the same way that you have to do it. So you need to do those questions and bring it separately. I'll be checking, not an instructor or not a paper panel member. I'll be checking it by myself at the end of the class. And if you haven't done it, you might have to wait till 8 o'clock and complete the work and go. If your parents are there, even they can come and like keep watching whether you are working or not. Okay, because I'm doing it. Listen it. That is additional work, and I make sure that I complete all the theories and all type of past papers inside the classroom because this is a physical class. So even though you won't join the live session or even you won't watch the recording, that doesn't mean that you can't understand the polynomials lesson properly. So I'm doing that as additional work, and I'm doing a commitment from my end, and I'm doing it. So I need you to do that commitment even. Okay, so next week, make sure you do the work and bring all the work of this polynomials YouTube live session. And the other thing is next week we are having our main paper. So main paper means the previous paper we had was just a small basic mathematical concepts. That is not even a paper. So from here onwards, we'll be recording all your marks in a Excel sheet properly. So we consider this one as the main paper one. Okay, it's next Tuesday. Listen. So we are starting the class at 3 o'clock. From 3 to 4:15, I'll be solving the remaining inequalities in the tute. And then a small interval, and 4:30 you are having the paper. The paper is timed 2 hours and half, 30 minutes, but you can complete it in 2 hours. So I am giving you additional 30 minutes. So the paper is 2 hours and 30 minutes. So then 4:30 to 7 o'clock we are having the paper. Clear? So next week we will be doing this inequalities, and someone remind me, I was supposed to do this 2012 polynomial question remaining part where we require the inequalities, this knowledge what we did today, but I couldn't do it. Next week, someone remind me, so you need to do this 2012 polynomials question remaining part. So then all of you should cover it and come, and next week we are having the main paper. And I need everyone to write the main paper except students who joined recently. If I have talked to them and if I told them, okay, you don't have to write the main paper, that's okay. If not, if you want to continue with the class, if you want to continue to do maths, you need to write the main paper. If not, you should have a solid reason with your parents' authority. Okay, because we are doing maths. Maths should be done in the way that maths should be do, not in a way any other subject we have to do. And the test is consisting of polynomials, recurring decimals, and inequalities. The easy paper. So I'll make sure if you have done your homework properly, if you have worked not in this overnight working, if you have just worked in a normal good level, you can score more than 90. If you have worked in a decent level shape එකේ අර පන්ති ඉවර ටික කරලා ගෙදර ගිහලා පොඩ්ඩක් ආයෙ ටික ආයෙ රිවයිස් කරගත්තා නම් you can score more than 50. But if you haven't done any homework, if you haven't worked at home, only by the knowledge that you gain inside the classroom, you won't be scoring more than 50. Clear? So if you are thinking to write this paper like the way that you wrote a O-level paper, O-level class paper, okay, you think you know this lesson, you are coming to straight away to the paper and write it, mark my word, you won't be getting more than 50. Okay, unless you are a high IQ person. If you are a high IQ person, meet a react 9, you can score and get like more than 75, 80, because I have done that back then. If you are such level, you can do this. But if you are a decent worker, you can score more than 75. And even if you have worked a bit hard in a level up way, you can score more than 90. And I expect students to score more than 90. And even if you do it perfectly, you can score a perfect 100. Clear? So next week, let's meet at 3 o'clock. And the paper is at 4:30. We are done for today. You can go home.